The electric circuit is the pre-established path that an electric current will take. It is composed of different elements that guarantee the flow and control of the electrons that make up electricity. Electrical circuits are present in every installation that uses electrical energy, like they are indispensable for the operation of appliances and machinery. There is a certain logic to organize a circuit, and much will depend on the installed infrastructure. That is why they are usually diagrams in advance to cover potential mix-ups. Electrical circuits are not only present in buildings, but any walking device implies one.
A battery circuit is one of the most important things to the electricity. It's a circuit that permits the travel of the electricity. It's like a river that has been divided into parts. All the streams go back to the same point from the out to point on another once again. This is a image. This is the parallel circuit. Has the 2 points and the circle.
I want to talk about the series circuit. One characteristic to note is that a series circuit only has a single current flow path. Now, what is a series circuit? It's that circuit that has more than one resistance, but only one path through which electricity flows, and all its components are connected from one end to the other end. As I already mentioned that they only have a single current flow path, since all the components will have the same current that flows through it. But if there is a break in any resistance, the circuit will fail. Main characteristic to the series circuit: current. It will do the same, goes through all the components of a series circuit. Resistance. The total resistance is equal to the sum to the individual resistance. And tension is the total tension is equal to the sum to the individual tensions. Well, its elements of the series circuit are electric source, resistance, and ideal conductors.
Fourth type of circuit is composed of 2 or more groups of resistors connected in parallel, and these branches connected in series, as in this figure. Or 2 or more branches in series connected in parallel between them, as I show in this picture. This type of connection is called mixed circuit.
Oh, hi, I haven't seen you guys. This time I will explain equivalent resistance, current, and overall voltage. Let's see the explanation. First, equivalent resistance. The equivalent resistance is equal to the sum of the resistances that form the circuit. The current in each one of the resistors is the same for all and equal to the current that circulates through the circuit. The overall voltage or difference of potential is equal to the sum of the voltages of each resistance. Now the next thing I'm going to explain is this. The reciprocal of the equivalent resistance is equal to the sum of the reciprocals of the resistances that form the circuit. In order to determine the resistance equivalent of two resistors in parallel, it can be calculated in the following way. The total current in the circuit is equal to the sum of the currents of each one of the resistors. The overall voltage or difference of potential is the same in each resistance of the circuit. And that's it for today. And remember, we don't make mistakes, we have happy accidents. Thanks for watching.
Now I'm going to explain one of the circuit exercise that come with an activity. This exercise asks us the equivalent resistance, the total current of the circuit, and the type of the circuit. The first question I can solve it by adding all the resistance because the circuit is a series circuit, and I can know it by the shape, this shape. And here the last question was also answered. And for the second question, I use a formula where the total voltage is divided by the total resistance, and that gives us 1 amp. And that's all for this exercise. Thank you.
Ohm's law states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points. Introducing the concept proportionality, the resistance, one arrives at the usual mathematical equation that describes these relationships. That is, A is equal to B divided by R. B is the voltage measured across the conductor in units of volts, and R is the resistance of the conductors in units of ohms.
An switch in your house that controls a single bulb is a series circuit, the most common every day. Series circuits are the electrical circuits found in homes and vehicles, with the difference being the type of voltage used in each one. Series circuits are used in areas where the operation of the circuit is required to be linear. Water heaters use a series circuit. Freezers and refrigerators both use series circuits. Lamps also operate on a series circuit. Possibly, the most noticeable series circuit at home are Christmas lights on a Christmas tree. Admittedly, it is not a daily life example, but more like one in 365 days. I mention Christmas lights as a good example because many people rest each year with taking the lights out from last year, put them on the tree, and discover that a quarter of the lights don't work. This is generally down to one detective bulb that has several series connections that connected a group of bulbs. It is a great example of how other elements in an electric series circuit are dependent on each other in order to continue functioning. And it's probably the most easily explained example of an everyday series circuit. The fact that all the lights don't fail in this instance is generally due to a typical set of Christmas lights, made up of 4 or more series circuits.
Well, at conclusion to this video, we have a final question. Why is it better to use the LED bulbs than the other kind of bulbs that exist? Well, the LED bulb is like an incandescent or fluorescent bulb, but with the difference that use less energy or less watts to produce the same amount or energy, or possibly more amount of energy that the incandescent or fluorescent bulbs, and that means that produce more lumens per watt. and have a very significant difference with the other kind of bulbs because approximately consume 80% less of energy than the other kind of bulbs. And if you change all the lights of your house or bulbs to LED, you will see the difference in the account that you will pay at the end of the month. Well, other facts about the use of energy in these kind of bulbs is that doesn't release energy to produce heat that doesn't happen with common bulbs. For example, the incandescent or fluorescent bulbs that on average produce or waste 45 watts to produce heat. Well, the LED bulbs also have a longer rate life. On average, they will last over 17 years, so you don't need to worry to change this bulb very usually. That is very common with the incandescent or fluorescent bulbs. So, the LED bulbs are more efficient. You will save money with this, and also more resistant if I don't tell you. So, I think that's all for this video, and thanks for watching.